Today we were discussing about baddies. I think this is a very useful topic for you. Okay, so we saw what is a baddie definition, what is a baddie implementation. Okay, then we'll try implementing any baddie. We randomly will pick some baddie and we'll try to implement it. So before that, we'll just see what are the different types of baddies in my system as well as by definition. So in system we saw like single use, multi-use and filter baddies. So similarly on my theoretical level there are two types of baddies. One is you can just say classical baddie, okay, and my second one would be I'll put it here only. Then the second one would be kernel baddie. So kernel baddie is nothing but my filter baddie. See, two things here. A filter baddie and a baddie filter is different. Okay, so by filter baddie you'll have to give by definition, and filters in baddie is like only the way we can filter. I mean, you can trigger the baddie for that particular conditions. We just saw that, right? I'll just show it again in the system issues. Okay, so what are the differences between these two baddies? Okay, so first one is my fallback class. Okay, fallback class. So we'll see. So majorly there are some four differences. Okay, so we'll see one by one. I'll just explain both for all this, both the baddies. Okay, one is my interface call, interface. Then the third one would be syntax, and fourth one would be, fourth difference would be my execution speed. Execution. Okay. So these are the four major differences we'll be discussing. So what is a fallback class? Okay, fallback class is nothing but, suppose we have baddie definition, baddie implementation. Okay, so if there is no active implementation for my baddie, it should come back. The control should come back to my calling class. Okay, that is called fallback class. So in my classical baddie, it is not there. Okay. Then the same will be available in my kernel baddie. This is a filter baddie. This is available. Okay, this is the first difference. Okay, the second one would be the interface. What all the interfaces we will require for my baddie in the interface tab, that will be by default available. You need not to specifically mention that, available by default. Here not available by default. This is the second difference. Okay, third one would be the syntax, how it is getting called. See, baddies will be generally you will not have any chance to write the syntax, but just to identify whether it is a classical baddie or a kernel baddie. For this will be useful. This is used by call method. Okay, but so call method, what will happen is, see, this is my baddies are always instance classes. So my instance is created by my CL exit handler. So yesterday we saw that step, right? Get instance. So the instance will be generated through that, and my method will be called using call method. This is one big difference actually. In my kernel, what will happen? There are two statements. Okay, one is my get baddie, get baddie. Okay, so get baddie, what it will do? It will get the instance of the baddie, and call baddie. So this will call my implementation. Call the implementation. Okay, this is the third difference. So when you come to the execution speed, okay, this we are in this method, the classical baddie. Okay, this will be slow because the instance is being created generically, okay, using that CL exit handler, and then it will be executed. But here it is directly called. Sorry. So here directly what they are doing is get baddie and they are calling the baddie. So this will be faster compression. It will not say the best speed, but compared to classical, this will be faster. Okay. So these are my major four differences between my classical baddie and my kernel, that is filter baddie. Now let me go into the system. So what we will do is, maybe yesterday we saw purchase order. Let me go and see if I have any sales orders. I think no data available, but still before running the transaction, in any process, business add-ins are predefined by the SAP system. You cannot create a baddie, but you can implement a baddie. Okay. Now we will try to find a baddie and we'll try to implement it. Okay. So if you know the baddie, you can directly go to SC19. This is for implementation, and SC18 is for definition. We have noted down the transactions, so it's okay. See SC18 and SC19, definition and implementation. Okay. So if you know the baddie name, you can directly give search, try searching here. So if I say maybe randomly I'll give MOPO something, F4, some things we have RDM promo post something we have. Okay. So this is enhancement. So if I see display, this is only the definition, but inside you can also see my implementation. So these many implementations are there. Double clicking on my implementation will lead to my implementation screen. So this will come from my SC19. So now we'll try to find out baddie from my SC24 from a business process. So there is a standard class called CL exit handler. Okay, so this will handle all my baddies. CL exit handler. If I go to display, get instance. So if I put a breakpoint here, so all the instances will be generated here and you can catch hold of the baddies which you want. Now I am just trying this VA03. This is for display sales order. So we'll see if any baddies are there. For instance, I'll just take the name baddie SD sales. So this is one baddie which is available. So I want to just implement this. We'll see what are. So it will keep on executing. How many our baddies are there? It will keep on executing. So I just got hold of one baddie. What was that? This was the baddie BD SD sales. Okay, so I'll try to implement this. So this will also have a definition by default. SC18. I'll see what is the definition. Baddie name, baddie sales. I just remove the debugger. This is not required. So every screen will have a baddie actually. So that's the reason it will keep on triggering. So if you see, this is a classical baddie. How you can tell is, see, within SAP, this filter dependent is not filled. So if this filter dependent is filled, you can give the filter type here and what values. Okay. So if these two are checked and this is not checked, so this is my classical baddie. That is how we can understand. So what is the interface we have? So we have so many interfaces here. Okay. So there is no implementation class. So what will happen if we try, we call the baddie, there is no fallback class. Okay. So it will, by default, it has gone back to my class which has called it. So that is the reason this is a classical baddie. Okay. Now see, there are no implementation classes. Now I'll try to implement this. I'll go to SC19. We are trying to create a new implementation. Okay. So class baddie BD says create implementation. Okay. It's provided by SAP. Okay, it's not allowed internal use. Let me try finding some other baddie then. Catch hold of some other. This one, let me see if it allows. Definition itself doesn't exist. See, so this one is allowing. Okay, let me see how we can do it. Okay, so if I just create implementation, it will just ask for implementation name. So generally, what we can do is just use easy, just for identification. That's it. Okay, so I'll click OK. This is how my implementation looks. Okay, implementation of body. So if you see definition name, it will come this one. Definition, because for this definition we are doing implementation, and this is of all multiple use. So you can create multiple definitions. Okay, sorry, multiple implementations for this body. Okay, specify filter values. Okay, it's a filter dependent. So we'll have to do the filter values. So this already has a filter type KAPPL. So this would be either a domain or a data element. Let me see that in S11. So data type. So this is a data element. Okay. So KAPPL is my domain. So it has a value table. Means it will, when you give F4, it will give all my values. So how many are there? 102 values are there. So similarly, same 102 values we will get it here. See 102 hit list. Okay. So if you want to specifically, if you want to specifically run this baddie for any particular value, maybe if I say customers, I can just give the customer. I can I can add all my maximum possibilities, all 102 values I can give. So I can maybe I'll give two customers. I give maybe another one sender I'll give. Okay, now I'll just save it. For two, I have given the implementation filters. So this is my. Okay, let me come back. Okay, now I'll just see what is my interface. See, name it, it the default created one implementation class. See, this is the interface, and this is my implementation class. So this is my baddie name, and GCL underscore IM stands for my implementation. So example implementation class is this. So if you want to see, refer some code, you can just open this in my SE24 and see this. So if I display, so this is how, this is already as an interface. Okay, this interface has one method, data selection. So that method will by default come into my methods. Okay, so implementation. So this is how it gives a sample code saying, boss, this is how it will look like. Okay, for data selection. Okay, now this is my example. If I go to my actual code, so now what is the method? It's there. It will list out here. It is an ABAP code. Okay, there is another called VSR formula. Nowadays we are not using it much actually, so we can ignore that. So if I go to my implementation class, double click it, or you can navigate. Or you can just copy paste. I have double clicked it. So here you can write your code whatever you want. So now what we have done is we have created a small link in the standard business flow where all my data is available. See, this is my import, this is my import, and this is my changing. So if you want to change some values on my runtime, you can just change it. So this is how my baddie works, and this is how you can implement it. The only limitation in bad is you cannot uh, get extra fields. So if this is my definition, only this will be coming into picture. Attributes. So this is my standard class. It's okay. The parameters you cannot edit. It says parameter of inherent methods or events cannot be changed. So whatever the system provides, you will have to use. So you should be very careful while picking what baddie you will have to use. Okay, so that's on my baddies. Now let's go back to our oops concepts. So we started baddies because it is on my oops instance classes. So on my oops, what all we saw till now is static classes, instance classes. Okay, some issue with the system. Let me reconnect. System is down. Okay, let me check what is the issue. I'll just go on mute for some time. Let me connect with the basis guys if there is any issue. Okay, just give me 5 minutes. Huh?
Is anyone in SD module?
I think all are technical guys here.
OMG.
SD module. Any specific clarifications you have? Or?
No, no, I'm just generally asking, Raj.
Okay. 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 No issues. Some network issue maybe. It has connected again. We'll continue. Okay. Okay. So now we were discussing yesterday like okay instance classes, static classes. So what are singleton behavior also we saw. Okay. Now there are two other things which are very important in my oops concepts. One is exception classes. So let's see what are those exception classes now. C24. I'll take one exception classes example. Then we'll create one. Okay. See, exception classes always starts with CX star, and when you define it as an exception class, it expects the alphabet X in it. Okay, so I'll just show what all are available. So these many are there. Okay, so what is an exception class now? It is so in the process of maybe you are creating a sales order or a purchase order or any business logic you are executing. There are two ways you can tell the system like there is an error. Okay, so what I can do is either I can just give a message and leave it, or I can handle, I can raise an exception. So what is the only difference between my exception and messages? Message it just shows, but this is your message. That's all. But exception class, it's a type of an instance class. It will be available all over my process execution, and you can collect the values. Okay. So I'll just show maybe one exception class randomly. What all it will have. So these are by default it will have. Okay, if message is my standard I mean interface it will have by default because it should collect my messages. Get text, so it is a written message. Okay, get long text, these two will be there, and other interfaces based on my requirement. Okay, So if it is a type of class, it is exception class. So here you can see this is an exception class. Okay. Then if you want to have any text, like message, we have two ways of doing it. I'll show you both. Okay. Better we'll create one C24. Okay. So what I'll do is I have an see basic. There are some exception classes like static, dynamic, and all. Maybe I'll use one of those, and we'll create an example. Okay. Happened. System got stuck. Is it? Okay. I think, yeah, working fine. Now exception classes, even in my customer standard, CX or GCX is my common. I mean, it is expected actually. So what I'll do is I'll just create a ZX class. So I'll just give GCL. We'll see what will happen. Exception demo is the class. Okay. So let me see whether it will accept or not. I'll just create demo for exceptions. Okay. So if I give an exception class, see it says the class name is not permitted. You will have to change it. So I'll change it. So GCX I'll make it. Okay. Okay. Now it will take. So if you see by default, if you give CX, it has become a child class of my CX static check. Okay. This is because this is a default implementation of my uh, exception classes. Okay. So here we have one option with message class. Okay. So what is this with message classes? So if you want to raise some messages, you can either directly give the text in my class level, or you can create a message class like in SE91 and you can use it, and by default it will become a final class. So I'll give with the message class. We'll also create a message. We can give it, see only the difference and maybe the help here is if you use this with message class, you can reuse the existing messages, or whatever messages you create can be used by other exception classes. That is the only reason here. Okay. I'll give with exception class. Let me see. I'll just put it in a package. Okay. So if you see this get text, get long position, and this one source position have been come from my interface. See, this is my interface. These are coming. So these two are from the standard interfaces. This one it added from my CX root, my child class. So if you see, this is my parent super class. If I double click, it will go there. So CX root is my base for all my exceptions. So try to create, by default it will inherit. So this is my root class. See, this is does not have any super. So whatever is there here, interfaces. So it will IF message, it will be there. So it will just inherit my other classes. Okay. So let me go to my methods. Okay, attributes. So these are the attributes available. Okay. So now what we can do is in the exception class, we are trying to use my maybe what we say this message classes. So let me create some variables. My message class or my message system variables, there will be four actually. Data type SYST, message ID, message number, message type, and the other four variables are there. MSG1, 2, 3, and 4. I'll just show that this is my system parameter. The system structure, sorry. Where is the diva? See, these set of fields are always used for my messages. So message ID, message type, and message number. MSG 1, 2, 3, and 4. This is just to hold my messages up to 200 characters. So each is 50. So now we'll have to create these four variables. Okay. So just to hold my message values, I'll just give 4. Okay. These are my associated types. So my all my Sorry, let me clear this. See, all my exception classes, parameters or methods should be instance because we are creating an instance of it. Visibility will be public. Okay, so I have created 2, 3, 4. Okay, I'll just save it. Okay, now I'll just create a message class or I'll just raise an exception first. Okay, so I'll have to raise the text, right? So for these 4 messages, I'll have to raise a text. So what I'll do is just go to text. So this exception ID by default it will come. My class name will come here. Okay. If you want to add any other exceptions, you can add it. Okay. So now I'll just double click. Sorry, message text. So here it will ask for message class, message number, what is the message, and all the 4 attributes. Okay, I haven't created any class here. So if this is the difference it will ask. So if I remove, change, sorry, doesn't come up. I haven't saved it. Okay, let me add it again. Create demo for exception class. Now I'll give without message class and we'll see the difference and then we'll go ahead. Okay, it is not saved. Let me catch hold of that. Okay, so text, let me see. Okay, properties, message class is not there. Okay, let me create one message class, or what I'll do is I'll just use any existing class. Okay, I'll just go back to my text. For message class is SC91 Z star. So I can either create a new or I can just use what is existing. So randomly I'll take something. I'll see some other things. It's okay. I'll create it, no problem. Z exception. I'll create. I'll just give message class for exception. Okay. Save it. Okay. In messages, we can give it in 2 ways. One is I can just directly give, or I can just give some placeholders. So what I'll do is I have 4 attributes given there. So I'll give 4 placeholders here. Maybe I can say placeholders 4, huh? 1, 2, 3, 4. 1, 2, 3, and 4. Exception class. Okay, I'll just give the text. Message save. Okay, activities. So this message 000 is my message. So go here, message class. If I just click, it will show what are all there here. Okay, so let's click on enter. It will give the text here. Message class 1, 2, 3, 4. And attributes, whatever you want to pass, you can pass it here. You can map it. So in my attributes, I have given 1, 2, 3, and 4 message ones. Okay, so I'll just map those. Why 4 attributes we are getting is because of that MSGV. It's a standard text. Okay, so all my standard messages will have this. 3 message class number type is what generally it will come as error only because it's an exception class. Otherwise it will ask for type as well. So 4 attributes I have just mapped it. So now whatever text you are giving it will come up. So see message 1, 2, 3, and 4. Okay, hopefully it will be fine. Okay, now I'll just save it. just activate it. We'll try raising this exception from my program. So we have one ABAP program, right? So you can raise it from anywhere, not only from ABAP program. You can raise it even from my classes, but this is just an example I'm taking. The ABAP built on. Okay, let me take this. So I'll just comment out all this code. So if you know that what all the exceptions will come up, you'll have to declare that as a reference. Okay, so first thing would be my data declaration. So we'll see the syntax also here. Okay, then we can raise the exception. Raise exception. Okay. So now the general way of calling this is there is a syntax called try and try. Okay, try. You see try. It will give try, enter, and catch. So catch is used for my exceptions. We'll see what are the combinations available here. So try, okay. So if you see, we have catch, resume, retry, and clean up. Okay. So if my this is just to control my flow. So my code within my try and try block, whatever it's there, it will just catch all my exceptions. If you want to catch the exception, okay, this is one. Catch and clean up, these two options you have. Catch means if you just suppose you have an exception raised inside my code, suppose you call some class, okay, there in some code it has raised an exception. So syntax for raising exception is raise exception, what is the type of exception you want to raise. Okay, this is the syntax. We'll just go that. Okay, so after catch you can write code what you want to, what it should execute. Suppose if you want to raise, see general cases, what it will be is it will raise an error. So if you can catch what all exceptions you have, you can just raise an error, simple. That is for catch. So this one there is another thing called cleanup. Okay, it's an optional block. Okay, it's not mandatory. You can see that's why it didn't come up here. So try, enter, catch only has come up. Okay, so there is a statement called cleanup. Okay, so what it does is it will just go and clear all my exceptions which are previously triggered. Okay, so let's see how we can raise the exception which we created. Okay, now the data declaration, what we should have is data, that exception will have to uh, let me declare the root exception you will have to declare. Okay, so what I will do is lx local exception. Okay, or you can also give lcx, but generally they'll ask for in two characters, lx root. Okay, type. So I am referring to that class, so it should be type ref2. Okay, so type ref2 is when we'll do is when you try to create some instances or you are trying to what you say refer to some other classes, you will give it. So our class is gcx. I'll just copy that class name, not this. This one, cx demo. Copy it, copy cx demo. Okay, then I'll just declare one variable for my message, lv message type string. These are the only two declarations I'm making. That, because my message will come as my string. Okay, so I'll just save it. Okay, now inside my catch, instead of, see, this is an exception class. Okay, so what I'll do is I'll directly raise exception. Okay, so what is this exception? Here it is. See, where is that exception? Text. So this is the exception ID. So this one I can raise. By default, it will be my class name. If you want to add another exceptions, you can keep on adding. So I'll try. So generally what they will do is if I call my class, if any exception is raised inside my class, then my catch set will be executed. So now I'm directly raising just for my example purpose. So the syntax is raise exception. Okay, what type of exception you should give it? Type. This is the exception you want to raise. Okay, so now you want to give that message parameters, right? So in that attributes you can always export my exception, sorry, parameters. So here I'll just give what is that attributes, these four attributes, right? I'll just copy all these four attributes. I'll just give values. Okay, one, I'll say just some text. Okay, so this text, it will come with concatenation. So whatever I gave here text, so exception class, I'll just give exception class, uh, exporting. Let me just prepare the syntax. Just give me a couple of minutes. Okay, export. I'll just give different. So this is like what I have given here. I'll just put a meaningful sentence. That's it. Nothing else. Okay. Exception class. Okay. Raised from SC38 program. This can be any text. Okay. So it's okay. Just for example purpose, I'm giving it. Okay. So if I export it, if I raise the exception, this will go and call my exception class. Okay. Now it in my catch, I'll have to give what is the exception you want to catch. So if you know that, it is fine. Otherwise, you can just give CX root. It will so CX root is my like my father of all exceptions. So if you don't know what exception will come up, okay, you can just call that CX root and keep it. So inside that you will always have an option to get the messages. Okay. So I'm just I know this is the exception, so I'm just catching it. So the syntax would be into my variable LX root. So if it is my CX root here, so it has all my exceptions. So whatever exceptions I catch, it will just come up here into this instance. We'll just see in the debug mode once. Okay. So what I can do is I have this message. I'll try to get my message text. Okay, equal to this instance class. So there are some instance methods for this. See, these are my instance methods. So get long text, get text, everything is at the. If you just click on control space, so these are the different things you will get. So these symbols represent, this blue one represents my attributes. This constant is like this is my interface. The methods will be coming up like this. Okay. So you see this get source position. It's not callable because it will be private. So if it is a public one only, you can call it. Now what I'll do is I'll put get text. Okay, get text will have only my returning parameter. So that is the reason it will not ask for any import or export. Okay. Now what I can do is I'll just write. So if exception is raised, a block between my catch and enter will be executed. Otherwise, it will not be executed. So I'll write my message. My write LV message. So this is the simplest way of calling my exception. Let me see if there are any errors. Hopefully nothing. Okay, I'll just activate it. So my expectation is these four parameters should go in concatenate with this exception class. Okay, I think typo error, it should be class. Okay, it's in my message, sorry for that, just a typo error, so we can ignore it. So it should concatenate exception class raised from SE38 program. So that is my expected result. We will see first the execution, then we will see the debug mode. See, exception class raised from SE38 program. So now we'll see how it is executed. Debugging I'll go so that you can see the instances of all those. So start of selection. Okay, this is my report. So I'm just raising the exception. See, so if I raise my exception, it goes to my constructor first. So as I explained yesterday, my instance constructor always has my super constructor. So that is called. Then what we have exported from my this my four parameters will be sent to my global parameters. See, message whatever I have given, you go to my global parameters. Then it will give the text. So this exception ID, whatever we have, message ID, we have put it in my text one, right? So that will come as declaration. So this is my message ID, message number, all the four. Okay, it will be set in my constructor. So it says an exception is occurred. So this will go into my LX root. So currently it is initial. After this catch, it will go. See, so this has my instance of this ZCF exception demo. If I double click, so this will all my have all my parameters. See, this one is my custom attribute. I mean whatever I have put that attributes. This is my root. Okay, so this will always be there. So the root has static and my custom exception. So it will show all my parameters here. So this one we already saw. What are my super class? These four navigations, and here it will click on this. It will lead to my, suppose you have, this is a very simple example of one exception, so this will not be much useful. But in case in debugging mode, you have executed maybe some 16-17 places the exception is raised. If you click this, it will navigate to the code, or it will show the code where the exception is raised. See, so in this method, in this program, we have used this actually. So we have raised exception here. So it will just navigate to the place where the exception is raised. This is a simple used case. Otherwise, it will be easy for us to find it out. Okay, so if I just execute, it will just display the method LV message. So this method is a returning parameter. It has only returning result. Okay, so whatever comes in the result, it will just push it back. So we got this into my LV message, the exception class, and it will write it. So similarly, you can try any number of examples. Okay, so this is on my how this exception classes work. So you can try a few more examples on that. Next I'll try, I think in oops, what else is left? I can also raise events. So let me check if I have any event for that. So see 24. Okay. So I have handle start event. So let me try raising this event in my SE38 program. So what is the event name? What is the class? These two we need. Okay. So now this is all about my exception. So let me. So for raising an event, you can just go to my back patterns. The exception we have already raised it. Okay. So we'll try to raise the event. So what is my class? This is my class. See, we have two events, start and end. Okay, so I'll use start. So raise event start, simple. So what will happen? If I just put this raise event start, the navigation will go to my handling method. So what is the start? If I give any parameters, okay, I'll give some parameters. So I'll say IV input 24. I just give one parameter. Okay, so you can just export it. So the values will be available in my event handler. So where is my event handler? Methods. I think the same. We'll just see if it accepts the value. Okay, I'll just activate it. I'll try to raise the event and I'll put a breakpoint just for debugging. And pattern, ABAP object patterns. The start, I'll just raise it. See, exporting in one parameter. So you can just pass that value. I'll say my input, sorry, IV input equal to 5. So this value will be sent to my this errors. Okay, what was it? Okay, sorry. We should write only in my methods. Okay, I'll put it in a method basically then. So raise event should be created in my object oriented context, not my SE38 context. So what I can do, put somewhere add static. I'll say if my LV number is initial, I'll raise this exception here. Pattern message event demo app. I'll maybe start here. Just remove this comment. Okay. So what I'll do is it's a static method. So I can call this method directly. CCL demo app. So pattern demo app. I'll just copy this. Sorry. CCL it is. Pattern call method add two numbers static. Okay. So by default it will give all my values. I'll just click make it. So now what I'll do is I have raised the exception if my LV number one is initial. So we'll see how this will behave. So the expectation is it should go and trigger my event handler. Okay, so let me execute. I'm not giving any values. So what is the purpose of this event handling is you can just trigger, I mean, instead of calling this particular method or static or instance method, you can use this event handler if you want to initiate some calls, like for example in the suppose in the creation of my sales order is a process. Okay, so now there is a start and end. So start will give my maybe my sales order number. So instead of giving a creation of my function module or like give next number like that, you can just raise this event and just catch hold of that value. That is possible. I'll just try to give a business scenario. I'll try to pick it up if I come across anywhere. I'll just give that. So if I just come here, call, oh, it's a class constructor. Okay, so my number is initial. The CV number, it will raise an event. Where is that? Oh, I think I haven't put my breakpoint there. Let me put a breakpoint in my event handler. It should actually go to my event handler. static only. So where is this method? Okay, now implementation is given. Let me try. Okay, let me try re-executing the program. Start of selection, constructor, the number doesn't come. Let me see. Didn't stop, so maybe some issue with my declaration only. So let me check what is the issue. To static, importing. Static and public. Okay, let me check what is wrong here because it will waste a lot of time. So I'll just note down what is my action point. We'll see next topic called something called field symbols. Let me event handler. Okay, okay. So let me now discuss something called field symbols. Okay, so we will just put this back. Demo ABAP field symbols. Okay, see field symbols are placeholders. So what is the difference between my work area and my field symbol is work area will have a separate memory allocated to my it will have a separate memory allocated and it will be whether used or not based on the usage it will just keep on changing, but field symbol is just like a pointer in my C++ Java demo for field symbols. Okay. Let me show how it works. So there are a couple of statements, a different set of statements for that. So what I'll do is I'll just do a data one. We just check that Mara table. We'll just try to read some 4 5 values from that MLC. Mara type standard table of Mara. Then I'll declare. Okay, I'll just keep this one alone. Okay. So now I'll just declare field symbols. Field symbol syntax is field symbols. Okay. These are the arrows, 2 arrows, fs, and whatever name you want to give, you can give. Okay. Then now the advantage here is we can either give it a specific structure, okay, of that field symbol, or I can give a generic. Okay, so we have multiple options here. Now I'll give Mara. Okay, then I'll give fs Mara st means structure. I'm just type any. Okay, then another one I'll give fs Mara table. Okay, so I'm not assigning any specific structure here. So it's any table. So dynamically we can do that. Okay, so we'll see how we can do all this. So I'll just select some 5 entries. Select star from Mara to table. Mara to. See, there is a restriction up to how many rows you want. We can just select it. So there are different syntaxes we can use. They'll say select single is there, and select star up to one row. These are the two different syntaxes. So there will be a lot of debate on this when to use what. So we'll see how we can use it. Okay. Now, so now different ways here is, now I can first I'll do the loop. Okay, loop assigning field symbol. I just do it fs. Okay, so it's like loop at lt mara. So if you don't have any field symbol already declared, here assigning is a statement. Okay, either you can give this one which is already declared on the same name. Okay, assigning field symbol. Okay, so if you doesn't have any declarations, in my new syntaxes we have inline declarations. So directly here you can give my what is it, sorry, yeah, some network issue, sorry. So if you don't have any declaration, you can just give assigning field symbol. What happened? Okay, there's the syntax. Now I already have the declaration, so I'll leave it. So I'll just activate. We'll see how it behaves in my runtime. The sorted table, sorry, it should be standard table. So some syntaxes will also have a loop. This is, I think it's fine. C38 field symbols. Just debugging. Okay, so now we'll select 5 rows. See 5 rows. So LT Mara F. See FR is it says it is not yet assigned because we have just declared my field symbol, but we haven't assigned it. So if I just keep a loop, okay, it will be assigned. So same thing. See, this is the values. This is how it will look like. So say similarly, the only difference between my work area, as I said earlier, is the way it holds my memory. So this is my dynamic memory. Double click, it will say, it will show the values. There is no difference in how it looks actually. The structures, first Nora. I can show the description where it comes. Let me try another. Okay, this is one way we can use it. So there are certain statements which we should check. Okay, so some basic checks. If so by default it will be assigned only, but we'll sometimes what will happen if we are in a loop. That is the reason it will come inside only if it is assigned. Otherwise, what will happen is it will just dump saying it is not assigned. Okay, so let me just try fs mara matnr. So before it assigning itself, I am just trying to write this value. Now we'll see what will happen. The basic scenario of where we fail to catch hold of this value. Okay, now if I just execute, I'll put a breakpoint here so that it will be easy for debugging. Execute. See. In debug mode, yeah, it will show like it is not at assigned. In real time, it will dump. See, it It says field symbol has not been assigned yet. Okay. So the basic check what you will have to do when you are dealing with the field symbol is you should check whether it is assigned or not. So what is the syntax is? If fs mara is assigned, okay, then you will have to continue with it. Okay. So now we'll see whether the dump will come or not. It should not come because we are checking for the assignment. See, this is not assigned still, so that will skip. So this check works. Okay. So this is the basic check you will have to put when you are executing or when you are using my field symbols outside my loop, because inside my loop what will happen, only if it's assigned or my loop is successful then only it will go inside. So this is very common mistake we will do actually. So this is one purpose of field symbol. Now the other advantages we'll see, or we'll try using any table. Okay, so these things we will try. Okay, now what happens, we can also use it as a variable. Okay, so now what I'll do, I will declare one material number. Let me do matnr type matnr. Okay, so this will hold only my material number. Now two ways you can just assign that value to my material number. One is, so here you come up, okay, my fs material number. This is a structure single value. So sorry, I'll make it fv. Sorry, it's a variable fv matnr equal to fs mara matnr. Okay, so this is one way of assigning. Then another way is there. Maybe I'll just give another material number matnr1, assign component matnr of structure fs mara. So this is a simple case, so that's the reason you will not need it. See, this is a direct assignment. Okay, this is a indirect assignment. So you are just giving based on a component name. So this will have problems when see everything is in dynamic. We'll see this one will get executed or not. We'll see. Okay, assign to my fv matnr. So this is possible when my matnr is already, see this one we have already declared is at matnr. Okay, in case now keep it any. So what will happen is it can accommodate any variable in that. Okay, so let me see whether this works or not. So I'll tell you one use case. Okay, so now in processing, see this will not have any structure. Okay, suppose this one, if you take this fe matnr, we have assigned it specific structure. I mean it's a variable. So we have something predefined we have assigned, but matnr one we have declared as any, so that we can for any variable you can use it. Okay, so this is how you can assign for that value. Let me see if this works. Let me debug and show. Where is this one? Let me open another session. 38. So if I go, so once it is assigned, see now it will come up. My matnr is there, my value. So this will get assigned. No, field symbol has not been assigned. Okay, some dump. Fv matnr, we have just given the type. We haven't assigned any value for that. Let me comment this out. So with see, we have just declared the structure of this. So we'll have to assign some value. Okay. So now we'll show how to assign it. This is the component of a structure when it is a generic type. So when it is a specific type, we can say, I'll just see what is the syntax we can assign it. Assign. We'll see whether this will work. See, because here we already assigned, so this one will work, the FS Mara. But this one we haven't assigned, so this direct assignment will not work in field symbols. I'll just trigger it. This is not yet assigned. See, now assigned it has taken. Okay, so my field symbol should always have some assigned values. Okay, now if you see FP Matner, it has a value. So we are assigning this value to my this value. So now this MATNR1, it is not yet assigned. So what I'll do is of this FS Mara, this MATNR component means I'll just show. Sorry, this is my Matner directly. FS. So if you see, this is my component name. This component. See, I can assign any component because it is generic purpose. Okay. Uh, Matner. So this value should get assigned to my Matner1. So let me come up, assign it was executed. So this has my Matner. Okay. Now maybe randomly I'll declare 2-3 variables and we'll see. So Matner I'll just remove or I'll just add another 2. I'll just put any one and any 2. So I can assign these components. So if I know the component name, so Matner I have. So what else I have in my Mara table? MAKTX will be there. So I'll just assign 2 components and we'll see how it behaves. Alright. So MATNR already I have assigned. Okay. So I'll basically take maybe ER name and who has created it. This is one component and maybe another one MTART material type. Okay. See. So now if any1, this is any. So I haven't given any declaration. It is a generic one. Okay. I'll just give size of equal to 0. Okay. So we know that this component is there in the structure. Suppose if we know that this is not there, we'll have to see the best way of doing it after every assigned statement. We'll have to check the size of RC. Okay. So for this MTART, the size of RC will work because we know that component is there. Okay. Now I'll just put another statement to my any3. Okay. So MTR 55. So just to make sure this particular structure is not there in my this component is not there in my structure, we'll see what will happen. So my size abasi will go for non-zero value. Okay. So these are some like the standard practices so that it will not dump. Let me just re-execute it. This is okay. This is the one we already saw. Okay, this is not at assigned. So sorry, this one material. Assign the value. Then MATNR has gone to my MATNR. Okay, then ER name. If you observe for everything, size of RC is 0 only. Okay, so means it assignment is proper. Anyone CMSR, this is my ER name. MTRT, it has been assigned to any two. Okay, structure MTRT. ER name and MTRT. Let me see what are the values. ER name and MTRT. Okay, MSR and MSR. That's correct. I thought the same values have come up again and again. Now, this MTRT 55 is not there in my FS. So, this will not get assigned. Okay, so now you see size of RC has gone to 4. So, in case you want to use this FV any 3, we should again put a check saying if this is assigned, then only continue with the logic. Otherwise, it will dump. Let me just try this again. What I'll do is I'll directly put maybe without this check, I'll put right. So in this case, it will dump. Okay, just to make I'll just show it. Breakpoint. I'll execute again. Refresh. Execute. Same. So it will say the field symbol is not assigned. Okay. So that should be this is a very critical point. I say field symbol not assigned yet. So whenever you are trying to use field symbols, you will have to definitely make sure put this condition. If FVNE3 is assigned, then write. Okay. Now we'll not have that error. I'll put maybe, or I'll just remove this. Yeah, I'll just remove this. Now it will have a value. I'll just make sure it doesn't have a value. See, if it is not assigned, now it is not assigned. See, so this in debug node you will know. So it will skip it. So the dump will not come. So these are the various ways you can use your field symbols for dynamic assignments where you will not have your any specific declarations. You can reuse the variables again and again. Okay. So now I'll just see if I can take an example of table. So this table I'll try to assign Mara to sorry, table. Let's see if this works. Okay. I'll put my breakpoint here. So till now we assigned structures, single values and variables. Now we'll try assigning tables. So when this has a proper structure, you can use like this. Otherwise, there is another syntax called hyphen in star. Like this, you can give it. Then it means bus assign all my components to my this particular table. I'll give that only. Let's see if it works. No, it doesn't. So it's not a reference table. Okay. So this will come up only in my references. So this has a specific structure LT Mara. Instead of this, if we give like type ref to some other value or my tables from my reference classes, you can give that. Sorry, not reference classes. Instance class will have some instance tables, right? At that point of time, you can give it. So then I'll put if size of RC. See, these are just various usages of my field symbols, not exact scenarios actually. So based on your exact scenario, you can write your code. Printer, activate. Mara will have 5 entries. Let me see this assign works or not. This is not yet assigned. Yeah, it works as a bar 60. If you see, it's a dynamic table. It is all these entries. Same 5, 5 rows, 228 columns. See, exactly same structure it has come up. So we can just reuse this variable however you can, because I have put it as any table. So if in future if I say boss I just want to assign another table, assign it. So it's like single variable, I use it multiple times. Suppose I have 5 tables with this, okay. MA, Mara, Mardi, Marci, Mar, E, okay, or a description table. I can just declare one variable as type any, okay, and you can just use it back. But what the problem will be is you cannot directly take the values out like this. You'll have to take out like values like this only, because this doesn't have any predefined structure. So the my fs mara will take my lt mara structure. So fs mara, if you just see, it will have predefined structure. So fs mara we have given. So if you remove this and put it as type any, this statement will not work. It will say fs mara does not have a component called matter, because it is of type any and it will not have any predefined elements. So this, in this case, line 31, it is a predefined case. Sorry, I think some screen has come up. Let me show that as well. So I'll just take it as any. Okay. So this is just how you play around with your parameters. Okay, nothing specific. So going forward, you will get used to it very easily. So now if I just save, check, see, it will say the data object fs mara has no structure, therefore no component called matter. So you will have to assign it in the same way we did it here. Assign structure of like this, we'll have to take it mara, this one you'll have to do, then it will accept. Okay, assign component of, I can just give it fs. Okay, this itself will not take. So fs mara, I can just take it as material. So instead of writing this syntax like ffe matner equal to, you will have to write it this way, because everything is dynamic. So what will happen is, if this component is there, then my size of bars will be 0, otherwise it will be 4. So you will have to handle it accordingly. See, now with the single variable, we can use how many our fields you want, you can use it, reuse it again and again. What invalid syntax for, okay, so just comment it out. So in my use case, what will happen? Suppose I have to manipulate with 5 fields in my Mara table. I'll declare only one field symbol, keep on dynamically assigning it. So it will save a lot of space. This is when only I have 5 fields. See, Mara is a very big table. So I want to have my 50, 60 fields. I'll declare only one field, keep on reusing it. So that is the best way we can optimize your program without using the work areas. Okay. So that's it for today. So what is the pending item from mine? So event handler, I'll just see why it didn't get triggered. Most probably I'll just also check if I have left out anything in my oops. You can also just go through the topics and let me know if you feel I have missed anything. We'll discuss it tomorrow. Okay. Okay then. That's it for today. Thank you. Have a good day. Bye bye.